All right, so now it's time to talk about constant opportunity cost. We talked about increasing costs before, where the curve is then bowed outward. Now it's time to talk about constant costs. So I have coconuts and fish here. Now between 400 coconuts by themselves or 800 fish by themselves. So it's a constant linear equation. You give up the same amount of coconuts if you have to produce one more fish. Constant opportunity cost. Now, for this, we have to figure out the per unit. It's hard to figure out per unit when looking at increasing opportunity cost because it's the outward, bowed outward, but now it's a little bit easier with constant opportunity cost. Okay, so how we do that, we look at, for one fish, we've got to think of how much coconuts we have to give up. So to produce one more fish, how much do we have to give up of coconuts? That's our opportunity cost then of producing one more fish. What we have to give up in producing of coconuts. So one fish, this is an output related question. I'm looking at the output of fish within the output of coconuts. For output questions, for output, think O, O. Other goes over, sorry. So the other goes over. We have one fish. The other 400 coconuts is going to go over fish. 400 over 800 equals 1/2. This 1/2 gives us our per unit opportunity cost of producing one more fish. We have to give up a half of a coconut. So the per unit cost of one fish is a half of a coconut. We can do the same thing when we're talking about coconuts. How much one coconut would cost? Other goes over. 800 over 400 now is equal to 2 fish. Think about it, it makes a little bit of sense as well. One coconut, if you give up 2 fish, get back down here to 0. I mean, thinking about 400 or 800, what it costs. It's constant opportunity cost going all the way down. So one coconut would equal to 2 fish. So that is per unit cost. That's an output related question. For input now, a lot of times input is how many hours it takes to produce fish or a particular product. For input questions, I've seen this a few times on the AP test. Input, think I, O, U. Input, other goes under now. It's kind of flipped off and reversed. Output, the other 400 over 800. But now for an input, like based on usually input like how many man hours it takes to create something, the other, put that in the denominator. Then that's how you figure out the per unit opportunity cost for an input related question. So output, input. Now I'm going to talk about terms of trade. We'll have two guys trying to produce coconuts and fish. One guy can do it for 400 and 800. Our second guy, let's do number 1, and our second guy can do it not quite as much. I'll say 200 and 200. Guy number 2. So absolute advantage, comparative advantage. Absolute advantage, we find out guy number 1, guy in the black here, has an absolute advantage in both coconuts and fish. But he doesn't have he only has a comparative advantage in one of them. Now for absolute advantage, it's just plain and simple, who can produce more if they're only producing coconuts? Who can produce more if they're only producing fish? Now comparatively, you gotta look at the per unit opportunity cost. So comparatively, we have to see for guy number 1, we already know one fish, let's go 1F equals 1/2 of a coconut. Or for guy number 1, 1 coconut equals 2 fish. Now for guy number 2, I'll do in red, same color as this curve. For him, 1 fish, 200 over 200, the other goes over. So 200 coconuts over 200 fish equals 1 coconut. Same thing for the other one. 1 coconut equals 1 fish. Now I'm going to look at, all right, who should specialize in the production of fish? Guy number 1 can make can get one fish at an opportunity cost of a half of a coconut. But guy number 2 can do it for one full coconut. Well, guy number 1 is more efficient at producing fish because he can produce it at a lower opportunity cost. But guy number 2 is more efficient at producing coconuts because he can produce one coconut at an opportunity cost of only one fish. Well, over here, one coconut costs 2 fish for that guy. So now we know the terms, or who should be exporting what, or who should be producing what. Guy number 1 should be producing fish, because it's a lower opportunity cost. Guy number 2 should be producing coconuts, because it's a lower opportunity cost. Now, terms of trade, a little tricky. We think of it in either what one coconut should equal or what one fish should equal. So we have these 2 equations. This is what we're going to be using for this terms of trade. Now, we have to set some value equal to each other. Meaning we have coconuts and fish, we have to make sure that, but they have sometimes different values, we have to make sure they're going to be equal. Well, I made this a little bit easy for us, 1 to 1. I know one fish over here and one fish over here. So I know one fish needs to be traded for in between 1/2 of a coconut and one coconut. So some value greater than 1/2 and less than 1. Use X as our trading value. So we'll trade one fish, he's producing fish, for in between this value. Anything over 1/2, he benefits because he is benefiting because it's more than he can produce by himself. And anything under 1, this guy benefits. Now, if we were looking at coconuts, one coconut should equal or be traded for in between. Well, it's hard now because one coconut is only 1/2. Well, basic algebra, we should be able to double both sides. So 2 fish equals 1 coconut. So now we have 1 coconut, 1 coconut. So 1 coconut should be traded for between 1 fish and 2 fish. X and X. Anything within this value, between this range, both people or both guys will then benefit from terms of trade. So that's how you do terms of trade, comparative advantage, use per unit opportunity cost. That's all.